Hi, and welcome to Rails tutorial. Today's topic could be on polling. Please like, share, comment, subscribe to this YouTube channel. Thank you. So, polling. Previously, we talked about frictional force, normal force, and weight. Now we're looking at polling. Pollings are devices that changes the direction of the tension force in the cord that slides over them. So this is a pulling, and this is a load. It changes the direction of the tension force. That's what the pulling does. It helps to change direction of the tension force. So if you look at this image, there's a tension that was going down this way first, then this pulling took it up, then now it's taking it down. You just change the direction of it. So because of this change in directions, so many factors are being applied in terms of pulling. We have like the force of the weights, the normal force, the force of tension. Those are what will be applied to this. So let's assume a table that has a mass here, a pulling, then another mass down here. So this mass is a small mass M, and it's a big mass M, bigger M. And there's tension rope here, another tension rope that goes down this way. And here is the pulling. So now this, we have a mass being pulled here, and we have a tension that goes down this way. So for us to look at this table, if you want to derive the force applied here, we know that on this table on a flat surface, here we have the force of the weights, which is equals to mg. And here we have the normal force. Then here is the force of tension, the force of the rope, the force of tension. So in this case, the force of tension is equals to the force of the weights. So here the Ft is equals to ME on the table. So now the one hanging on the ground, that is the force pulled hanging on the ground. Here now, this place here is the force of the weight, that is the mg, right? Then this tension force here, you have the Ft, because that is where the rope is applied on. But where's the normal force in this case now? Because the rope is applied up there, the Ft has occupied force of the Na. Now, in this set, we'll now have it as the tension force here will be equals to because now since the tension is opposite, is in the other direction, the tension force here would be Ft minus the mass, the big mass of the weight, which is equals to mass negative acceleration, because it's in the opposite direction. So if you want to look at this accurately to get the holistic force applied, it will be this force on the table, substitute the force of the table to the tension force on the hanging rope. Right. FTMA, this is like equation 1. Then this is like equation 2. 1, then second equation. Let me substitute the value of these two. We've seen that this FT is same as this mg here. Now we'll say if one substitute the value of this equation, this FT can cross out, this one can cross out this. So this mg would be big mg is equals to small ma plus big ma, right? Taking the items together, so the big mg will be equals to a over small m plus the big M. So we can also say the big mg divided by small m plus big M is equals to A. That is the acceleration. So here is the acceleration of this full pulling. That is the big M over times g over small m plus big M. Now we will apply it in the subsequent questions, examples. But just note that pulling are devices that changes the direction of the tension force in the cord that slides over it. Okay, let's look at some examples. Let's look at this example. In relationship with what we just explained initially, is a mass, is smaller m, is a bigger m. Now we're asked to find assuming that the mass of m is 2 kilograms, the small mass, and the big mass is 10. The coefficient of friction is 0.5. Compute the acceleration. I know when I explained the initial time, this force here, this Ft minus the force of friction, because of the friction here, F of x is equals to ma. That's the first for this on the table. Let's call this equation 1. Then the first hanging, the tension force here, Ft minus the weight of the mass, big mg, is equals to mass negative acceleration, because it is. So maybe one wants to now substitute the value of equation 1 into equation 2, then we can have it as mg, when this f cancels out this f in substituting values, so we can now have m capital, the big M g minus this f of f is equals to small ma plus big M A. All right. And for this, let's just substitute the smaller ones again. So to be, I will know this F of F, frictional force is the mu, that's 0.5. So here to be M, the big mg minus mu mg, which is equals to minus coefficient of friction mg is equals to a bracket small m plus big M. Then we can also say this M the big M minus coefficient of friction small m over all of this is like bracket of G. Then we have it's equals to a bracket small m plus the big M. Now we're looking for the acceleration, so makes acceleration the subject of the formula. So A will be equals to big M minus u m over m plus big M. So when we substitute the value, this big M is 10 minus mu is 0.5 times this 2 kg. This top one would be 0.5. Mu times M is 0.5 times 2 kilogram, that is 1. So 10 minus 1 is 9. 9. So there's gravity here. Let's not forget G. 9 over 2 plus 10 is 12. That's 12G. 12G. So therefore A is equals to 9 over 12. When we divide this 9 over 12 will give us what? 9 over 12 will give us 3 over 4. 3 over 4 G. And G is 10, right? So 3 over 4 G times 10, that will be 7.5 meters per second. Per second square. Since 3 over 4 is 0.75 times 10, that's 7.5 meters per second square. So the acceleration used on this, the computed acceleration for this block is 7.5 meters per second square. So then in the previous example, calculate the tension in the cord. So we know the tension from previous example. We're calculating the tension in the cord. And formula for tension is what? Ft is equals to M, which is equals to, we have the mg, we have this mg minus m, the acceleration we got there was 3 over 4g, right? Over m 3 over 4 gravity. That's the gravity acceleration we got there. So that for us to make this easier substitution, by the time we subtract mg from this, we'll have it as just like saying Ft will be equals to mg minus mg 3 over 4g. So the difference will be 1 over 4. 1 over 4 mg. So now let's substitute the value, which is equals to 1 over 4 the mass of the big M is 10. And the acceleration is 10. Is 25 Newton. Okay. So that's the force of tension of the cord. Okay, let me know if you have any question. You can put them on the comment section. Please like, share, comment, and subscribe. This is the end of Pulley's class. The next one we'll be looking at inclined plane. Okay. Until the next classes, please like, share, comment, and subscribe to the